Hello everyone, my name is Ofer Asaf, and I am excited to present you with our work in progress, Plantimus, a plant stethoscope. Plantimus was designed and created in Qadar Design and Technology Center in Shachar College, Israel. I will start with the background and motivation behind Plantimus. We are living in troubling times, an epoch of mass extinction and massive climate change. In these complex times, cultivating responsibility towards a fellow species that live alongside us on Earth, such as plant, is of crucial importance. In this case, the sooner the better. Learning to nurse and nurture our planet should start at a young age. Motivated to encourage children to develop a nurturing approach towards nature, we designed Plantimus. It is an interactive external device which allows children to hear plants using interactive technology. Let's see some of the related work that influenced us while designing Plantimus. Plantimus allows children to hear plants by creating a digital layer on top of nature. The concept of augmenting information over the physical world was shown effective for children's outdoor learning experiences in the work done by Rogers and her colleagues. In their project Ambient Oren, sounds augmented on top of the physical surroundings promoted exploration and discussion regarding the natural environment. The idea of hearing plants is not a completely fictional idea. A research group in Tel Aviv University has shown that plants emit remotely detectable sounds when stressed. With Plantimus, we did not try to amplify those sounds, but rather use part-specific sound to create an educational and playful experience. Now let's go through how Plantimus is designed. Wanting Plantimus to be an external enhancing device meant for exploration, we borrowed the metaphor of a physician's stethoscope, which is rich in connotation of caring and nurturing, as well as revealing the sounds of the most precious inner parts. Similar to a stethoscope, Plantimus is built of two main parts: the plant piece, which is directed towards the plant, and the earpiece, which is directed towards the ear and emits sounds. The two parts are connected by a string which houses the electrical wires and allows Plantimus to be hanged on the child's neck while exploring and wandering. A crucial part of the design was the process of sonification. First, we created 3 sound libraries for the 3 main plant parts: flower, leaf, and earth. Each library contains 2 types of sound. The first is figurative sound, which communicate information regarding the part role in the plant's life and health. The second type is abstract sounds, mainly musical sounds that create a more rich, textural, and playful sonic experience. When the plant piece is directed towards a plant part, the different layers of sound, both figurative and abstract, gradually appear, creating a unique sound pattern for each part. Let's look at the table for an example. When Plantimus is directed by a child towards a leaf, we will first hear a breathing sound, relating to the leaf's role in the respiratory process of the plant. After a few seconds, a saxophone sound will enter, adding texture. And finally, a water slurping sound will enter, indicating the water movement in the leaf venation. Now I'll show you a little demonstration of how Plantimus prototype works. The prototype is based on an endoscopic camera connected to a Mach Cycling 74 software. The software generates real-time sound according to the movement of the plant piece. Hi, now let's see how the Plantimus prototype works. Currently, the plant piece doesn't recognize any plant part and it's in search mode and emits white noise. As I'll direct the plant piece towards the flower and the camera will recognize the color pink, sounds will gradually appear. we tried a pre-prototype version of Plantimus with a group of 7 children at a flower garden in urban context. After they finished playing with it, we discussed with them about their experience. Here are a number of our observations. First, it seemed like the children enjoyed playing with Plantimus. They danced and engaged with it for many minutes and were excited to discuss it with their friends. Second, the children exhibited independent activity by trying out different plants and objects than the ones we directed them to. It was interesting to see that the children related to the abstract sound we chose, and that the figurative sounds promoted discussion regarding the role of the different parts of the plant. Finally, we noticed that Plantimus raised concerns regarding the health of the plants. Children asking how a dried up leaf would sound as opposed to an healthy one. In the future version of Plantimus, we intend to develop the following features. In terms of part recognition, we envision a more specific recognition of the plant part by image recognition software. In the sound design aspect, we plan to create a more plant-specific library that may relate to different health statuses, the plant origin, unique features, and so on. Currently, as you may have seen in the prototype demonstration, Plantimus is connected to a computer with a wire in order to work. In future versions, we hope to design Plantimus as a wireless device, which will allow a cable-free exploration in nature. That is the end of my presentation. Thank you very much for listening, and now I'd be very happy to answer any question you have regarding our work.